being cold, and I said, well, I saw frost once this winter. Oh, we're back on live. I'm sorry, talking about the temperature being cold outside here this morning. Before break, we were looking at how to do all this stuff in Excel, and hopefully everybody can do that. Most of you are far better in Excel than I am, so you probably won't have any problems with this, but for those of you who have never done this, you're going to have a little bit of a learning experience, but it's not too hard. All right, go back to the computer here, and let me just kind of get what I've got on here. So this is what we're going to do is do this kind of calculation. We're going to solve for the present value, and I'm just going to go back to home so we don't have all those formulas sitting up there type of thing. And we'll clear that off. Blank cell type of thing, and we'll go back and take a look at the problem. So let's flip back to the overhead or the camera here, and let's see how we can set up this problem here for the ABC Corporation. So I said what we're going to do this is we're going to write down 5 variables: present value, future value, the payment, the number of periods, and the rate. All right, let me read the problem again, because it's been a few minutes since we looked at it. The ABC Corporation has bonds outstanding that mature in 10 more years. Length to maturity is 10. That mature in 10 more years. They have an 8% coupon rate. 8% times 1,000 is $80. Now we have to specify 4, and we can solve for the 5th one, okay? Incidentally, future value, we know it is $1,000. So we're down to these two, the present value and the rate of return. Now, first types of problems we're going to do, I'm going to give you the required rate of return and ask you to solve for the present value. Later on tonight, I'll give you the current market price and ask you to solve for the rate of return. So those are the one or the other would be the typical, what we'll leave as an unknown here. Now in this particular problem, what do we know here? That the bondholders require a 10% return. And I pointed out to you earlier, I typically write these down as a percent, but 0.10 will work equally well for you. Either way you want to do it is fine. And then present value is equal to an unknown. If you would, on an exam, write down the 5 variables, write down what 4 of them are, and indicate which one is the unknown, and then write down equals, and we'll find an answer to put in here in just a minute. Now, if you want, you can set this up straight in Excel. You can go to one cell, you can go down for the first 5 cells and write present value, future value, payment, down the line. And then in the next column, you can write down what those variables would be. And then when it comes time, you just click on those variables when you want to put them into the formula. And you'll have a cell with an answer in it. And then on the exam, just print out the Excel sheet, and I'm good with that. If you want to write these down on a sheet of paper and just write the answer in, I'm equally good with that. So any way you want to do it. Don't just give me an answer. Because if you make a mistake, which who doesn't make mistakes, and all you've done is you put down the present value is equal to something, and you either hit all this in Excel and I can't find it, or you didn't write, I mean, whatever. How am I going to give you partial credit? I mean, it's the wrong answer, and there's nothing there to show me what you got right on the whole thing. So write it down either like this, or write it down one column in Excel this, the next column put this in there, and then print that whole sheet out. Whichever way you feel more comfortable with, I don't care. I'm good with whatever you want to do. Excel, so switch cameras here on me. And we want the present value, so we'll go equals present value Now, actually, Excel wants you to put those in as capitals, but if you do them lowercase, it doesn't know. It'll switch them up someplace. It'll put them in up there on, and then we need to put the not bracket but parentheses. I'll probably say bracket 10 times tonight, but it's a parentheses. And then first thing it wants, it tells you right below there, and that's one reason why I make these big, because I can now see them. It wants the rate, and the rate here I'm going to put in as 10%. It will work equally well if you put that in as 0.1. So whichever way you want to do it. But when I write 10%, I know I've got 10% in there. If you write 10 and don't put percent down, what's 10? It would be 1,000? 1,000%. So you're going to get a real strange answer. So if you go back to here, go back to the overhead quickly here. If you tell me here it's 10% and then you go in Excel and make it 1,000% and get a strange answer, I'll take a point off. But you've showed me here that you know what you were trying to do, you just didn't do it real well, type of thing. So that's a minor area, and I'm not really worried about that. But if you don't show me this and you put in 1,000%, you're going to get, I'm going, how did they get that? And and so then you lose a lot of points. So don't lose a lot of points. Make sure you can give up. I go back to the Excel here now. So 10%, and then don't forget the comma. And it wants the number of periods, and that is 10. And the payment here was $80. Did I miss something here? Oh, I can see what. It's all right. Future value is 1,000. Don't put a comma in there, because if you put a comma in there, it's going to read that as 1, and then a whole bunch of zeros for the next variable. So don't do that. Make sure it's 1,000. And now, next thing it wants is the type. The type means this. Do I get my $80 of payment right now, or do I wait a year to get that $80? And it's what they call beginning or end of time period for the payment. Do I get the $80 today, or do I get the $80 a year from today? We always assume that it's at the end of the time period. So for all our calculations, no matter what it is, type will always be 0. You have a choice. 0 is end of time period. 1 is at the beginning of the time period. And it changes your answer just a little bit by a little compounding factor there. And I'm not going to, it's always end of time period. And then don't forget to, can I say close the bracket? Just wants to make you feel good about that. So close the parentheses and then just hit enter. And it came back $877.11, but it's in the red. There's a reason for that. The way Excel looks at it is this. It says, if I pay means a cash outflow. If I pay $877.11 today, I will get $80 a year for 10 years, and I will get $1,000 at the end of the 10 years. And those, with the present value calculation, are equal. So the $877.11 is viewed as an outflow, and the payment and the future value are inflow. Now, if you don't like to read that in red, put the payment and the future value both as negative. So make that a negative $80 and a negative $1,000, and your answer will come back in the black as a positive answer. So either way, but I think it's easier only to read the answer as 877. So if we go down, come back to the overhead here. The answer we will write down here is $877.11, and ignore the negative sign there. And just ignore that negative sign. So that would be the market price. That would be the market price of that bond. Okay, now, some very important terminology and some calculations and some thoughts. And I always test all of these thoughts on the exam some way or other. So listen up very carefully. This bond, on the face of it, says $1,000, meaning I'm going to get $1,000 in 10 years. But I can buy it today for $877.11. Why? Why? And the answer is the relationship between these two percentages. This is only paying me $80 or 8% a year, and I require 10%. It's only paying me 8% or $80, and I require 10%. Well, how can I get my 10% if it's only paying me $80 or 8%? And the answer is I got to buy it cheaper. I got to buy it cheap. If I can buy it cheap, less than $1,000, then I can still make my 10%, even though I'm only getting 8% or $80 a year in interest. All right, this is known as a discount bond. Anytime the coupon rate is less, that means is less, than the required rate, I will have a discount bond. On last year's exam, I gave them a calculation, the first bond problem, and it turned out to be the price of the bond was less than $1,000. Then I had a B question. I said, is this a premium or discount bond, and why? Well, a lot of people said, it's $877, it's less than $1,000, so it's discount bond, and the why? Because it's less than $1,000. It's correct that it is a discount bond, but the why is because the coupon rate is less than the required rate. So this is the why. This is the answer to the question why. It's a discount bond because it's selling for less than $1,000. The why is because the coupon rate is less than the required rate. Discount bond. Everybody wants a discount, right? When you buy something, you want to buy it at a discount.
Not on this.
Well, somebody said not on this, but that's not necessarily true. The fact that I can buy the bond for $877.11 means that I am getting my 10% return. So that's okay. I'm getting my 10% return. The amount of discount, another question I frequently ask is, what's the amount of discount? It's equal to $1,000 minus $877.11, and that's what? $122.89? Did I get that right? So the amount of discount is $122.89. So I always ask two bond problems. And the first bond problem is I have you calculate the price of the bond. Bam. And then I'll ask you something, is it premium or discount? And I haven't given you a premium example yet, but is it a discount bond? And the answer will be yes or no. And either I'll ask you find the amount of the discount or I ask you why. And the why has to do with the coupon rate being less than the required rate. Okay, everybody good with that? So this is a discount bond. Now, we got a B on this problem, right? A part B on this problem. What does part B say? What would be the market price of the bonds if bondholders require a 6% return on their investment? How will we figure out what the price of the bond would be if it was a 6%? Answer, write down 5 variables. I can't tell you too many times. Write down 5 variables, okay? So present value, future value, payment, Number of periods and the rate. Okay. Present value is what we want to solve for. The future value is still $1,000. The payment is still got the same coupon. Still got on the bottom of, if this were bearer bond, we'd still cut off that 8% coupon. So it'd be 8% times 1,000 or $80. And same number of periods, isn't it? And what was that? 10 years, was it? 10 years. What's changed now is this is now 6%. So once again, you can set this up and do it right in Excel if you want, or do it on the exam and just write the answer right here. I don't care. Depends whichever is easiest for you. So some of you are so good in Excel, you do it that way. I've seen students, just, they just plop them out so fast it makes your head spin. And others are like me, and they write them down on pen. So, but whatever you do, but I don't care. I'm going to do it right here. And so let's go to the Excel here. And I'll just do it on the cell right below it. So once again, I want equals present value parentheses. And the rate now is, what is the rate? 6%. 6%. The number of periods is still 10. The payment is still $80. The future value is still 1,000. And type is always 0. Actually, I think, and I hate to make the statement, you double check it on me, I think if you just don't even put the 0 in there, just close the parentheses, it'll assume it to be 0. But I always put it in there just in case Excel's got a feeling funny that day. So if it's feeling funny, you don't want to get the wrong answer. Now, let's see. Anybody want to guess? I'm gonna just rhetorically thinking about this. Is this going to be $1,000? Is it going to be less than $1,000? Or is this going to be more than $1,000? Probably more than $1,000. Oh my goodness, a lot more than 1,000. Well, you cheated. You already worked it out. You crook. You answered more than you had it worked out. That's not fair. All right. 1147.20. Go back to the overhead here now and then. And 1147.20. Now there's two observations on this one. There's two observations that are very, very important. First of all, this bond is called a premium bond. Why? Because the price is more than $1,000. It's called a premium bond. And the amount of the premium is the 1147.20 minus $1,000, and that's an easier calculation. That's what I can say with certainty I'm going to do right, because we just dropped the 1 off there. It's 147.20. Now, what I am doing is I'm paying more than $1,000 for this sheet of paper that says it's worth $1,000. Why? It has to do with the coupon rate and the required rate. Notice I didn't put anything in between these. And what can we say here? The 6% versus the 8%, the coupon rate is greater. So anytime, so if I ask you why, if I say is it a premium or discount, this one we would say premium. And if I say why, the answer is the coupon rate is greater than the required rate. So the why is the coupon rate is greater than the required rate. Now, it's a pretty good idea to figure these out before you even get into making the calculation. When you see the data, like up here, ask yourself, is this going to be a premium or discount? Well, this one should be a premium. What if the number comes out of discount? You made a mistake. You entered something wrong. So you should have some idea what you're doing. So the first thing, all right, we've learned the words premium and discount, and whether they're premium or discount has to do with the coupon rate and the required rate. Okay, so those are some basic principles. I'll ask you a little question about that somehow or other. There's a second thing, and I always put this on an exam. Now, here I'm only requiring a 6% return, aren't I? And the bond was a premium bond. Here I required a 10% return, and it was a discount bond. Interest rates, what happened to interest rates? From here, it went from 10 down to 6, right? So I can write that interest rates, put the arrow down, meaning what? Interest rates went down. Bond prices go up. Some wise professor in finance, me, once looked at that and called that the law of reversing arrows. Is that what it is? As interest rates go down, bond prices go up. If interest rates go up, bond prices go down. The Wall Street Journal reports every day about interest rates and bond prices. And one day they'll say bond prices went up. The next day they'll tell you interest rates went down. They told you the same thing 2 different days, but they told you the identical thing. They always tell you one or the other, and they assume that you're sophisticated enough to understand that. Assume. Big problem with assume. But I will ask you a question on the exam. Something like, interest rates went up. What do you expect to happen to bond prices? They went down. And the next thing is why? And you can tell me there's an inverse relationship between interest rates and bond prices, or, which sounds more sophisticated, the less sophisticated way of saying is law of reversing arrows. I'm good with that. Since it's my exam and it's my law. And I'm grading it. I don't have a grader, so I'm good with that. So we've learned premium, discount, and the law of reversing arrows. Remember that. And you get tested on that. You will get tested on that. Now, let's move on to part C here. What would be the market price of the bonds if bondholders require a 10% return and there are now 9, 8, and 7 years? Now, I'm going to set this up as one big table. How do we solve for that? Write down 5 variables. Practice that. Say that in your sleep. Write down 5 variables. Write down 5 variables. I'm going to do this for present value, future value. I'm not going to do it all in Excel. We'll just kind of do this. I've been scrolling on that screen. I don't know how I've managed to do that. Payment, number of periods, and rate. Now, we're going to do this when the number of periods were 10, which we already did, 9, 8, and 7. Okay? 10, 9, 8, 7. When the rate is 10%, all the way across, the payment was what, $80, was it? $80, we're going to go $80 all the way across. Future value is always going to be $1,000. Now, rather than spending a lot of class time grinding through the numbers for you, would you believe the answers I have already worked out? This one, what was the first one? Was it 877.11? 877 and 11 cents. Now that's when there was 10 years to go, right? What do you think is going to happen when there's only 9 years? It's going to get closer to that $1,000. So I mean, I've got it worked out here as, let's see, 9 years. I got 8.84 and 82 cents, and then I've got 8.93 and 30 cents, and 9.02 and 63 cents. Trust me. Okay, I'm not going to work all those out for you, but trust me that works, okay? So we got these. Now, there's an observation based on this data that I want you to make. Here's the discount. What happens to the discount each time period? Gets smaller. What do you think it's going to eventually end up at, the discount, just the day before it bond matures? 0. It's going to get close to that $1,000. There's a graph that we use. And I will ask an essay question on your exam where you need to give me this graph. I don't know what the question is, but I know what the answer is. Somebody steal my straight edge? Yeah, you did. Graph will look something like this. I'm going to make it a little bit bigger than it needs to be right now because there's going to be a second half that I'm going to look at here in a minute. Here's the present value or the price of the bond. And that line is at $1,000. And this bond matures in 10 years. And it started out when there were 10 years left to maturity. It was it 877 and 11, right? Now, it's going to end up at $1,000. Is it going to be a straight line like this? Well, if you look at the data I've got here, the discount here is 122. And I got it worked out here. Then it's 115. Then it's 106. And then it's 97. I read through those numbers fairly quickly for you. But the discount is shrinking really dramatically. And it's not shrinking as a straight line. It goes something like that. The amount of discount is decreasing at an increasing rate. I hate to sound like a mathematician. That's always scary. So if we write discount in here, the discount is disappearing. And it's disappearing more and more rapidly. Is that another way of saying it? Figure out a way of saying that and make sure I can read it. So I'll ask you a question like, what will happen to the price of these bonds as they approach maturity? And the answer is, and I'll say, give me both a graphical and a written explanation. This is the graphical, right here. The written explanation is the bond approaches $1,000, and here it's approaching it at an increasing rate, if you want to say it that way. Or the discount is disappearing at an increase. There's a lot of ways of saying it.
Exponentially, is that accurate?
Well, exponentially could be either way, though. I think. Wouldn't that still be exponentially? I don't know. I'm not math. But so I think we want to make sure we got this doing it that way. If you drew me this graph and you said exponentially, then I probably would be good with that. Okay? Is there a part D on this question? Oh, yes. What would be the market price of the bonds if bondholders require a 6% return? Can I set up another table? Just like I did a minute ago? So let me set up another table. Let's see. How many variables do I write down? 5. You get it. Present value, future value, payment, number of periods, and the rate. The periods are once again what? 10, 9, 8, and 7. But the rate is 6%, 6%. I'm looking at the live class here. No one's doing this in Excel. So it tells me how fast you are in Excel. Don't take that as a challenge, please. Because people are really good at this, make a copy, and they just pop this stuff through. The payment is $80. Future value is $1,000. What did we have before? I don't remember. All right, I can read it off the screen. 1147 and 20. So this one's now. Think we're going to have a premium on these other ones? Yeah. What's going to happen to that premium as we get closer and closer? It's going to disappear, right? It's going to disappear. So take my word for it that I got these right. 1136.03, 1124.20, and a lot of 11s. 1111 and 65 cents. So it looks like that premium's disappearing, and eventually, if we were to run this all the way out to year 0, this would be $1,000. If we ran it out to time 0, it would be $1,000. Going back to my graph, what would my graph look like now? I'd start up here as a premium, right? At 1147 and 20. 1147.20. I kind of blurred that out a little bit. And it's going to be down here at $1,000. What's the shape of this curve going to be? Well, if I could take this and fold it over, it'd be a mirror, which I'm not real good at drawing these things, but something like that. So my premium would gradually disappear at an increasing rate. So my premium so you'll have either a discount or a premium bond. I don't know which way, I just pull numbers out of the air. Whatever it is, I'll probably ask you a question, what happens to the price of this bond as it approaches maturity? And you'll tell me it approaches $1,000, and then you'll give me this graph. One half of this. You don't have to do both sides of it, just one half of that graph. So we learned another important principle here, right? Around these important principles. Got one last one. Got one last point principle. That's the second problem. I write my own problems, and I have a heck of a job coming up with company names. As you can tell by the ABC and the RST, some people are really good at coming up with these little cutesy names. I could never do that. So the white, and if it's a name that's something else, if it's a name something else, usually what I'm doing is I'm sitting at my desk and I'm looking around the room. See, the lights, the television, my shirt, the floor. You know, that's so if I say whatever happens, some people come up with really some great names for things, and I just can't do it. The RST Corporation has bonds outstanding that mature in 20 years and have an 8% coupon rate. What happens to the price of the bonds if bondholders' required rate of return falls from 10 to 9%? Well, you know the answer, but we're going to prove it. What's going to happen to the price of these bonds? Interest rates fell. Law of reversing arrow says going to go up. All right, let's set this up. How am I going to solve this? 5 variables. Present value, future value, payment, number of periods, and the rate. I'm going to set this up with 4 columns. The first 2 columns are this part, and the second part of the problem are 2 more columns. So leave yourself room to put in 4 columns. And what do I have here? Bond matures in 20 years. So you got 2 bonds that mature in 20 years. They have an 8% coupon rate, so they're both $80. The future value is $1,000 in each case. And the interest rate falls from 10% down to 9%. So interest rates went down. If I were to calculate the price of this bond here versus the price of the bond here, interest rates went down, bond prices better go up, right? All right, I did this. And at 10%, it was $829.73. Trust me, I mean, you can go into Excel and do it, but I don't see any reason to keep beating it. $829.73. And here I got 908.71. Now, incidentally, if I were you, I would try and duplicate some of these numbers. Do enough of them that you feel comfortable that you're matching what I did, and then try some homework. But don't try the homework without matching some of my numbers, because it means you're probably making a mistake someplace. No, is that right? Now, see, interest rates went down, bond prices went up, right? Now, fairly large increase here, right? Now it says, what if the company has bonds that outstanding mature in 1 year? So now the number of periods is 1, is it? Is that what it says there? And interest rates fall from 10% to 9%. $80, $80, 1,000, and 1,000. Interest rates went down. What's going to happen to the bond prices? Going to go up. Now, first one I worked it out at $9.81 and 82 cents. Is that what you got? You imagine you're doing all right? And the other one I got at $9.90.83. Interest rates went down, bond prices went up. Now, a question that every time I ask it, I get 2/3 of the class kind of going, ah! So be the 1/3 that gets it right. There's a message here. There's a message here. And let me ask a rhetorical question here. Would you rather own, if interest rates are going to fall, would you rather own the 20-year bond or the 1-year bond? Interest rates are going to fall. Would you rather own a 20-year bond or a 1-year bond? Now, in both cases, the price of the bond is going to go up. The 20-year bond went from $829 to $908. It went up almost $80, didn't it? This one went from $981 to $990. It went up $9. Now, if you have to think any further about the answer to that question, you're in trouble with your finances. Would you rather have a 20-year bond or a 1-year bond? Oh, you people are in trouble with your finances. No, a 20-year bond. Why? The 20-year bond went up $80. I bought a bond for $829. The next day, interest rates went down. And my bond's now worth $908. Here I bought a bond for $981, and a day later it's worth $990. Now, either case I'm making money. But which one of those cases would you rather be in? I'd rather make $80 than $9. And the lesson is this. The longer the length of maturity, 20 years is longer than 1, is it not? Last time I checked. The more volatile the bond price. The longer the length of maturity, the more volatile the bond price. Very, very important principle. Probably the most important of all these things. The longer the greater or the longer the length of maturity, 20 years versus 1 year, the more volatile the bond price. If I think interest rates are going to fall, I want long-term bonds. I want to be holding a whole bunch of long-term bonds. What if I think interest rates are going to rise? And right now in the United States, we've got historically low interest rates. They can't go any lower. They can go higher, though. If interest rates are going to rise, or if there's a chance that interest rates are going to rise, what do I want to own? 20-year bonds or 1-year bonds? Now 1 is the right answer. If you say it enough, you'll get the right answer. Okay? More volatility. So if interest rates are going to rise, that means bond prices are going to fall, and I'm not going to get hurt as badly. So some financial advisors right now are advising their clients, don't buy long-term bonds, buy bonds that are going to mature in fairly short periods of time. Not if, but when interest rates rise. Because it's not a question of if, it's a question of when. When interest rates rise in the United States, then if you own long-term bonds, you're going to get really damaged. If interest rates rise and you have bonds that mature in 1 or 2 or 3 years, you're going to get hurt, but you're not going to get badly hurt. You're not going to get hurt as bad. So this is called interest rate risk. And it has to do as interest rates change, what happens to your bond price. There's a lot of interest rate risk with long-term bonds, and there's not much interest rate risk with short-term bonds. We interviewed, let me come straight ahead here just as a sidebar on this, just to give you a story. We interviewed, a long time ago, back in the 80s, we interviewed a candidate for a job at Kettering at the time. And the guy had recently retired, and he said before he retired, he had bought a whole bunch of bonds when interest rates were 15 and 16%. And at that time, interest rates had fallen to like 8%. And he was breaking his arm, patting himself on the back. Why? Interest rates fell, the bond price went up, and he had bought a bunch of 20 and 30-year bonds. He made a fortune. He made a fortune on it. Okay? So remember that. Remember that. That was a real story. That's not a hypothetical. That's a real story. So, but you people, you're going to have to be careful if you're buying bonds, because the danger, the risk you got is that interest rates are going to rise. Now, back in the early 80s, when interest rates were these double digits kinds of things, you could have gone up higher, but for those smart people, the lucky people, however you want to phrase it, when interest rates fell, boy, those people made a lot of money. They made an awful lot of money. Now, let's move on. Now, here's the home. I knew I had a set of homework problems here someplace. Problem number 3 I want to take a look at here. A bond has 17 years until maturity. Its current market price, now note, here we're giving you the market price, is $1,040.11. And its coupon rate is 10.5%. What is its yield to maturity? What do I mean by yield to maturity? All right. Yield to maturity. It's the return an investor makes if the bond is held to maturity. It's the return you make if you bought it today and you held it to maturity. Now, you could buy it today and sell it next week or next month. You don't have to hold a bond. There's a market for buying and selling bonds. But the yield to maturity means I buy it today and I hold it all the way till it becomes mature. Now, how do we solve for yield to maturity? Write down 5 variables. It's always the same answer. Always the same answer. Present value, future value, payment, number of periods, and rate. What do we know about this bond? Its coupon rate is 10.5%. So this will be 10.5% times $1,000. I changed the coupon rate on you finally, didn't I? So it's $105. Future value is $1,000. And this bond matures in 17 more years, right? Now, I buy the bond and I get these inflows, right? I get these as inflows. But if I buy the bond, I pay out, I have an outflow of how much? $1,040.11. But remember I said I pay out? That has to be a negative. If you don't make that a negative and you put these other 4 variables in, it comes back. I know it gives you some kind of a nonsense answer. I forget. We'll try it here in a minute. It's like pound lock or num lock or something like that. And essentially it means if you put all positive numbers in and you ask it to solve for rate, it can't solve for it. So it has to have at least one negative number. So the easiest thing is to make this negative and these 2 positive. You could make both of these negative and leave that as a positive, but I think convention-wise this is the easiest way of doing it. Let me go to the computer here now, and I'll drop down a cell here. And here I go equals. I no longer want to solve for the present value. What do I want to solve for? Rate. So if I go R-A-T-E, and theoretically that's capital letters, but lowercase works just fine. And then notice the sequence in which the information goes in is different. That's why you have to read underneath there. You can't just say, oh, I always put it in this way. It changes. Each time you change what's the unknown, it changes the sequence in which you put the data. What's it want here? Number of periods. Number of periods here is 17. The payment was 105. The present value. You want me to put it in as a positive or negative? Negative. I'll put it negative now, then I'll come back and change to a positive just to show you how you get to what you get for a wrong answer. So we'll do it both ways. So this is a negative. What was that again? $1,040.11. The future value is a positive 1,000. Now, the type is still 0. And I need to talk for a second here. Yep, let me scroll that up a sec. That's better. See, I didn't want to get it on the insert there. I can't move that thing enough on. All right, it wants a guess. And what this is this. This is a nonlinear function. And Excel's not real good at solving for nonlinear functions. A lot of variables in it and all that kind of stuff. So what it does is it iterates. Means it tries something and then it works and see how it works and keeps trying until it gets the whole thing to work out right. Now, in finance, instead of calling that an iterative process, we call that a SWAG process. That's an acronym. Acronym means it's the first letter from 4 different words. What does SWAG stand for? Scientific Wild Accounting Guess. For those, shame on those of you who thought something else. Scientific Wild Accounting Guess, okay? That's a SWAG guess. All right. Now, back before we had the fast computers that we have now, if you didn't tell it where to start, it didn't know where to start swagging it or start iterating. So you had to tell it something to where to start, and the closer you guessed, the faster, because these things used to go blank for 30 or 40 seconds back when, you know, this 30 years ago time. You can't, I know you young people can't relate to that, but they'd go blank while it was iterating back and forth. Computers are so fast now, it doesn't care. You can give it any guess you want, and it'll get there like that. What I always do is I always guess 10%. Why? No reason. I just put 10%. I don't think 0 works. You can try that. Your problem. So, and then we'll close my parentheses. Now, be very careful what I'm doing. Here's my answer. Oh, 10%. I guessed pretty good, didn't I? But I always put 10%. That is not a correct answer. Because the answer is not exactly 10.0000. When you ask Excel to solve for the rate, Excel always rounds it to the nearest whole decimal, so whole percentage. It automatically tells you 10%. What you need to do, and I have to get closer so I could read this thing, you have to come up to this little cell right here, not decrease decimal. We want the one that's going to increase the number of decimal points. Can you see that on the TV where I'm at there? So you need to come to the cell here, and it tells you increase decimal. Oops, I'm not on the cell, that's why. Sorry. You got to come back to that cell and increase the decimal points. 10.0, 10 point. Ooh, it's still pretty close to 10 point, isn't it? Ah! Now here I want 3 decimal points. So this actually, the answer would be 10%. On your exam, it won't come to a whole percentage point. And I can tell when you don't know what you're doing or you're forgotten. Because if it's supposed to be 6.555, it'll round that to 7%, and people write down 7%. But you got to get me 3 decimal points. So if it's supposed to be 6.555, I want 6.555. And you'll see why in a little bit. But first of all, accuracy-wise, I think there's a big difference between 6.555 and 7%. So just for accuracy-wise, you want to do that. There's another reason that'll come up a little bit later on. So make sure that you go to that little thing. Now, the older versions of Excel doesn't have that nice little thing there. You have the older one? I think it's View. You go to View or something like that. What is it? Format. Yeah, Format. That's what it was. Under Format. Under Format, and then you go to percent, and you can change your decimal point there. Format, then click on percent, and then you can change the decimal points there. I think that's what it does. Is that working for you? Mm-hmm. Okay, so you can. It's a little more cumbersome, not as easy to use as the newer version of Excel. That's why I always did it up until last year, and I've already forgotten how to do it. I just can't remember all these things. Some people never forget anything. So under Format, you can get that kind of thing. And incidentally, if you want to change the cell size, I think you do that under View. On your computer, you do that under View. If you click on View, it'll allow you to change the size of that cell, which makes them big like I've got here. So one way or the other. But everybody remember this. So this is the answer here. Really, I'll decrease my cells down to 3 decimal points. There would be 10.000%. That would be the answer I would take there. But in fact, it is a little bit different than that. So make sure that you can do that. With a probability of 1, I will have you solve for yield to maturity on the exam. And if that isn't guaranteed, I'm going to put it on, or I don't know what is. I just told you there's a problem on your exam. 2 problems on bonds, one on present values and one on yield to maturity. So you're going to have the yield to maturity calculation. Now, let me go back to the overhead here. This yield to maturity, the return an investor makes if the bond is held to maturity. That means each year I would get 10%. Each year I would get 10%. But this is a premium bond. And each year the price of it would go down a little bit, would it not? So I would lose a little bit money on the price of the bond, but I'm getting more money in annual interest. And we express this with a formula. What we say is, I'm going to use YTM as yield to maturity. YTM is yield to maturity. Yield to maturity is really made up of 2 things. It's 10% a year, but it's made out of something we call a current yield. Current yield plus a capital gains yield. So it's 10%, but these 2 numbers change each year. It's always going to be 10% in this problem, but how much of its current yield and how much of its capital gains is going to change. Remember the price of this bond? What was the price again? 11 or 1040? It's going to go down like this. So each year I lose a little bit of money, but it's not a straight line. It's going down faster. So I'm losing percentage-wise more money each year, which means that my capital gains is more negative each year, which means that my current yield is going to have to go up a little bit. So the sum of these 2 is always going to be the same. And the way we do this is this. The current yield is defined as the payment, how much interest I get each year, over the price of the bond. PV is the price of the bond at the beginning of the year. Price of the bond. The first year it's 1,040. The second year will be a little bit less, a little bit less, and a little bit less, and a little bit less, and eventually get down to $1,000 or approaching $1,000. So this divided by a smaller number gets larger. Capital gains gets more negative. All right, in this case, the current yield would be, what was that again? What was the $105, was it? Over $1,040.11? Yeah. And that turns out to be 10.095%. Now, I'm only making 10% on the bond, but I'm getting more interest than that. All right, let me go do a little, show you the form. Yield to maturity equals current yield plus capital gains, using a little shorthand there. Yield to maturity is the current yield plus the capital gains. This we solved at 10.000%. We just solved the current yield at 10.095%. Any chance we can figure out what the capital gains is going to be? Well, no. Capital gains. Remember, this is a premium bond. What happens to the price of a premium bond each year? Goes down. it's capital gains. Capital gains mean what happens to the price of the bond must be negative. The capital gain must be negative, so it's a negative 0.095%. This is why the second reason why I want you to get this to 3 decimal points. Because if you round this off too much, this equals that, and there's no capital gains. And I want you to be able, you have to have enough decimal points to give me a capital gains. So premium bonds, this is always negative. Might make a little note of that. Premium bonds, capital gains is always negative. What about discount bonds? If it's a premium, capital gains negative. If it's a discount, capital gains is always positive. Remember that price went up. Remember that. Today's a long lecture. I got more to go. I hate to tell you that. You're getting your money's worth out of me tonight. I'm not done. But it's one last topic, one last point. A lot of little points here on these things. And on your exam, I'll test each one of these things. I'll give a little problem testing each one of these things. So be prepared. All right, come straight ahead here a little bit. Let me talk for a second. Now, in the United States, people buy and sell houses all the time. Very common because they move, they get bigger houses, it's whatever. Other parts of the world, I have a friend in Germany, he's living in a house that's built on property that his great-grandfather owned. You know, got several greats in there. They're proud of living, but we move all the time. Meaning we get mortgages all the time, and we're doing all that kind of stuff. Now, what if Neil bought a house and the interest rates were, say, 10%, monstrous mortgage payment. And then 2 or 3 years later, interest rates had fallen to, say, 4%, like what they are now, say. Now, am I going to be walking around with a big smile on my face saying, boy, I got a 10% mortgage, and somebody else say, yeah, I got a 4% mortgage? I'm not going to be happy, am I? What would I like to do? I'd like to go back to the bank and say, time out on that mortgage, folks. If you lend me enough money to pay off the first mortgage, pay off that 10% mortgage, I'll take some of that 4% money, I'll what it's called remortgage or refinance my mortgage. And sometimes I go to a new bank and pay off the old one from the loan at the new one. And if I could get a mortgage at 4% instead of 10%, I'd have a lot smaller monthly payments. And when interest rates have fallen like they have over the last 20 years, we found that when they went from 16 to 14, people all the way down to actually some mortgages right now are below 4%. And people have been refinancing, doing it. Now, in the contract that we have with the bank, it allows us to do this usually. But bonds, some bonds in their contract, there's a little thing in there that says, you can't refinance this for so many years. And it's called a period of call protection. A period of call protection means, get this in your notes, period of call protection means it's the time that we're not allowed to refinance the bond. Remember earlier I was telling you about some guy that bought a whole bunch of bonds when interest rates were really high and they had fallen from 16 down to 8? Well, people that had these bonds paying him 16% interest weren't real happy. So they'd like to change the bonds in for some 8% bonds. Well, unless there was something very specifically in the contract that allowed them to do that, he was going to draw that 16% for 30 years. Usually what they'll find is this period of call protection saying, for the first 5 years or for the first 10 years or whatever it might be, you can't refinance. And that's period of call protection. It's a period of time you just can't do it. Now, what all investors should be concerned about is if I buy a bond and there's a period of call protection where they can't call it in, what happens if it is called in the earliest possible point? What kind of return do I make? And that's called, incidentally, when a bond is refinanced, it's called called. So if a bond is called, it means the old bond is called in and a new bond is issued. So called. And it's called the yield to call. And this is the return an investor makes if the bond is called, I hate to use that word twice within the definition, but we'll do it anyways, is called at the earliest possible time. So we got one of these bonds that's paying a lot of interest, and what we want to know as an investor, well, what if it is called in? What if they do reissue another bond? What kind of return do I make on the deal? For example, I should have a problem there. Where's the problems here? Problem 3C. If the bond may be called in 3 years. Oh, one other thing here. The bond may be called in 3 years at a price of $1,071.57. Now, if I'm a bondholder and the bond gets called in, that means someone's only going to give me $1,000. Big frown. Not happy. So in the contract, there's usually something that says, if this bond is called in, they got to sweeten the pot. They got to give you a little extra money. And that's called a call premium. A call price is equal to $1,000 plus the call premium. The call price is the price they got to give you to call the bond in. The premium is what they're paying you above $1,000. Here the call price is what, $1,071.57. What's my call premium? What's my premium if that bond is called in? All right, you can figure that out, right? It's $1,000 plus $71.57. On the exam, I'll either tell you the call premium is $71.57 or the call price is $1,071.57. I'll do it one way or the other. Now what we want to do is solve for this yield to call. How do we solve for yield to call? Write down 5 variables. I told you, you don't believe me. Nobody believed me. The answer is always write down 5 variables. Next week, the answer will be write down 5 variables. Present value, future value, payment, number of periods, and rate. Let me give you in words what these values are now. This is a little bit different. The present value is the current market price. I would say about a third of the students get this wrong on my exam, so make an exception this year and get it right. Fool me. The future value is the call price. Note it's not $1,000 anymore. It's no longer $1,000. It's the call price. The payment is the coupon rate. And one common mistake is to multiply it by the call price. That's not correct. It's the coupon rate times $1,000. Note, call price and $1,000 are different numbers. These are different numbers. Number of periods is length to call. And the rate is the unknown And that's called the yield to call. All right, let's see how we do this. Read the problem here for 3C. So present value, future value, payment, number of periods, and rate. What's the current market price of the bond? $1,040.11. Oh, I forgot to try that one with a positive, because that's got to be a negative, don't forget. Try hitting that with a positive on that other problem, just to tell me what the answer comes out to be. Can you hit that quickly? This is about the newer version of Excel. I don't remember what it gives you. Can you just go back and change that to a positive number? On 3A, that's too hard.
Number.
Pound sign or something like that?
Yeah.
N-U-M with a pound sign.
Number error.
If you get number with a pound sign, it means you forgot to make this a negative. A num with a pound sign means you forgot to make that a negative. Because I can't tell you how many students over the years say, "Well, I know what I'm doing here, but I can't get my computer to work. Excel doesn't know what it's doing." Well, somebody doesn't know what they're doing. The future value is $1,071.57. Now, see, what they're going to do is they're going to give us a little bit more than the $1,000. The payment here, what was that again? 105 was that? Is that right? Which was 10.5% times 1,000. Number of periods. Earliest it can be called is 3 more years. And the rate will be the yield to call. Let me try one more of these. I'm running out of time here, but I still think it's worthwhile to do one more of these. Equals, I want rate. Number of periods, what did we say, was 3. The payment was 105. What do I need next? Present value is a negative 1,040 and 11 cents. Future value was 1,071 and 57 cents. The type is 0, and I'm going to still guess 10%. You can guess whatever you want. Enter. Oh, where's that 11% again? What do I have to do? Go up here and increase the decimal points. Oops. First of all, I got to get that on the right cell. I'm increasing the decimal points on the wrong cell, and it doesn't work. 11% again. Whenever I have funny numbers like here, it means I've worked it backwards. I had this is an old problem I did before we had used Excel and everybody had fancy. I had to have it so it would work out right. But count on yours needing that 3 decimal points. Okay. All right, so make sure you can do that. And your bond problems, I got one last comment I want to make, but you've got problems up to problem 7. So you got 4, 5, 6, and 7. All kinds of problems there. I will put some of those on your exam. So it's very similar to what you got there. I have one last thing to talk about. And I've only got 3 minutes to do it. 0 coupon bonds. What is meant by a 0 coupon bond? I'll read it. Means the payment equals 0% times 1,000, which I can work out in my head. It's 0. Not getting any annual interest. So someone's going to borrow some money from you today, and sometime in the future, they're going to pay you back $1,000. Now, let's say they're going to pay it back in 30 years, and we're going to get like a 6% return on it. How much are you going to have to lend to them right now? And the answer is, these are what we call deep discount bonds. I didn't work out the numbers, but if I solve for with a zero coupon, in other words, zero payment, at a 6% for 30 years, it'd be like $100 or less than $100. I don't even know. It'd be probably quite a bit less than $100. It'd be less than $100. Deep discount bonds. Would you like to buy a bond for, say, $80 that in 30 years pays you $1,000? Well, whatever it is, that'd be a really good return, wouldn't it not? And there are people that do that. The way this, you come straight ahead here for a second. The way many of us have done it is that when we were born, our grandparents gave us U.S. savings bonds. Now, for those who were born in some other country, you probably didn't get that, but most Americans, or many Americans, when they were born, they got U.S. savings bonds. And the way a U.S. savings bonds work is it pays no interest. It's a zero coupon bond, and you buy them at a deep discount. Usually they mature in like 8 or 9 or 10 years. So like for a $100 savings bond, they probably paid, I don't know, pick a number for it, but $50 for it or something like that. And it's very, very common. And so these are big examples of deep discount. The U.S. government has zero coupon bonds out there that you can buy at deep discounts, and a small number of corporations have zero coupon bonds. It's an interesting way to invest. It's a very interesting way to invest. So just keep that in mind. The only downside of it, if it's in a taxable account, each year the price of the bond goes up, and the government figures out how much the market price went up, and you have to pay income tax on it. So they're really only good in IRAs and 401ks and things like that. I'm running out of time, so I don't know. Do your homework. Be prepared for everything I told you tonight. Boy, that's a lot. Okay, I think it's Miller time.